Welcome to aminacademy.com. In physics, let us discuss about interference and diffraction of light. In that, we have to understand what is coherent waves. Coherent waves are waves that have the same form. That means the same frequency and the fixed phase difference. That is the amount by which the peaks of one wave lead or lag those of the other wave does not change with time. This is a coherent waves. Now we will discuss about what is interference. Interference is a type of phenomenon which occurs when two or more waves overlap and combine together. This is interference. In double slit experiments, we can find that interference. It can happen with any kind of waves such as sound or water waves. Imagine you have two sets of waves, maybe formed from two different stones thrown into a pond. When these waves meet, they don't just pass through each other. Instead, they interact and combine in interesting ways. These are two types of interference, including constructive and destructive. Next one, constructive interference happens when the peaks, that is high points of two waves, line up together. This makes a new wave that's bigger than either of the original waves. Destructive interference is the opposite. That means it happens when a peak of one wave line up with the trough, that is low point of another waves. When this happens, the waves cancel each other out, making a smaller waves or even no waves at all. Next one, what is diffraction? Diffraction is a phenomenon associated with waves such as light, sound, or water waves. It occurs when a wave encounters any obstacles or slit comparable in the size of its wavelength. Diffraction also happens when waves pass through a small opening or gap. The waves spread out after they pass through the gap. It is a common phenomenon and can happen with any type of wave. Light waves diffract too, but it's more noticeable when the size of the obstacle or opening is close to the wavelength of the light. When light diffracts through a small slit or opening, it creates a pattern of light and dark bands known as diffraction pattern. These patterns can tell scientists a lot about the light, like its wavelengths. A good example is when you see a beam of sunlight coming through a small opening, it curtains and the light spreads into the room. Similarities between the interference and diffraction. We can understand what is the similarities between interference and diffractions. Interference and diffraction are both about how light waves behave. These are similarities, and they have some things in common. Here is how they are similar, explained quickly. Both are about waves. These both are about waves, it explains. Interference and diffraction happens with waves, the light or sound waves. They show us how waves can bend, spread out, and overlap. Superposition principle. When two waves meet, the new wave they create is just the sum of the two original waves. This idea is key in both interference and diffraction. Spatial pattern. Both interference and diffraction result in spatial patterns like fringes or bands of light and dark areas dependent on wavelengths. This pattern we see in both interference and diffraction depends a lot on the wavelengths or color or the sunlight or the light. Next one, difference between the interference and diffraction. Interference and diffraction are two important phenomena in physics. We know that the following table shows the difference between the interference and diffraction. First, interference cause. How it happens? Interference happens when two light waves meet and mix together. Meet and mix together is interference. It is caused by two or more light waves coming together. Diffraction happens when a light wave bends around a corner or through small openings. It is caused by light waves hitting an obstacle or passing through a small gap. Next one, source of light. Needs light from sources that stay in step with each other. That means for happening interference, there should be a light source. It can happen with light from just one sources. Here, diffraction can happen in one sources. Here needs light from sources that stay in step with each other. That means for interference and diffraction, there must be light sources. Pattern form. In interference, makes pattern of bright and dark bands, but in diffraction makes a pattern with a central bright spot and other spots that get dimmer further out. Requirements: the path difference between waves should be a multiple of the wavelengths. Path difference is the multiple of a wavelength, but here the size of the gap or obstacle should be close to the light wavelength. Uses and interference used in things like holograms and measuring tiny distances. This diffraction used in tools for splitting light into a spectrum like CDs, DVDs. This Young's double slit experiment is for interference. Single slit experiment shows how light spread out. This is for diffraction. Now, the spacing in the pattern depends on the light's wavelength and the setup. But here, the size of spread out light pattern depends on the wavelengths. Next one, what is coherent light? The source and the waves are said to be coherent if they have the same frequencies, same wavelength, same speed, almost same amplitude, and have no phase differences or a constant phase difference. If any of the properties is lacking, the source are said to be incoherent. That means coherent light or should be satisfied. That means same wavelength, same speed, almost same amplitude, and have no phase difference or a constant phase difference. Here, look at here, coherent laser light passes light accurately spaced, but here incoherent LED light is mixed light. Next one, the relative phase. What is relative phase? Relative phase is the difference in phase angles between two signals at a specific time. It's associated with the time delay between the signals and can be estimated for a given frequencies. Here are some ways related to phase is used in lights. That means relative phases of two coherent waves traveling along the same line together specifies their relative positions on the line. If the crest of one wave falls on the crest of the other, the waves are in phase. It's called in phase. If the crest of one fall on the trough of the other, the waves are 180 degree or 1/2 wavelength out of phase. Next, phase shift is polarized light. Phase shift is happening in polarized light when two waves pass through a brief fringent crystals. A phase shift occurs due to differences in electronic interactions. The relative phase shift between the two waves can be changed using a phase shift slider. What is relative phase? The relative phase shift refers to the difference in phase angles between two signals at a specific time. which can be calculated using the arctangent functions. It is associated with the time delay between the signals and can be estimated for a specified frequencies. Look at this figure, relative phase here. These two things together form a relative phase. Next, what is interference effect? When two or more waves interact, they can interfere with each other in different ways. For example, when two waves are in phase, they combine to create a wave with a larger amplitude. Two phase combine, it becomes waves with larger amplitude, which is known as constructive interference. When two waves are out of phase, they combine to create a wave with zero amplitude, which is known as destructive waves. It becomes destructive waves. Look at here crust and trough combine. Here trough and crust combine. So it's finally destructive interference. Constructive interference, both. Look at here, it becomes higher amplitude. Next, diffraction of light. Further explanation. Diffraction is the slight bending of a light as it passes through the edge of an object. The amount of bending depends on the relative size of the wavelength of light to the size of the openings. If the openings is much larger than the light wavelength, the bending will be almost unnoticeable. Next one, single slit diffraction. Single slit diffraction is a fundamental concept of wave of optics that explains how light behaves as a wave when passing through a narrow slit. When coherent light, that is like a laser, goes through a single narrow slit, the waves spread out and their interaction creates a pattern on a screen placed some distance away. This phenomenon, known as diffraction, leads to the formation of alternating bright and dark regions, showcasing the wave nature of the light. Now, here the formula is m dash lambda equal d sine theta m dash, where m dash is natural number 1, 2, 3, right, in order number of diffraction dark band is the order number of the diffraction dark band of the diffraction dark band. Next one, Young's double slit experiment. Here, pure wavelength light sent through a pair of vertical slits is diffracted into pattern on the screen of numerous vertical lines spread out horizontally. However, diffraction and interference, the light would simply make two lines on the screen. Here, this is an electron beam gun, that is a source of electron here. In double slit it passes, that interference pattern happen in the screen line. Limit of resolution. The resolution limit is the distance between 2 points on an object that can be distinguished in an image taken by an optical instrument such as a microscope, telescope or camera. It's also known as the resolving power. The resolution limit is due to diffraction, a physical phenomenon that limits the resolution of all optical instruments. The resolution limit is determined by the following factors, that is numerical aperture. That means the numerical aperture NA of the microscope's optical components like the objective lens. Wavelength of light. The wavelength of light is used to get a limit of resolution. Then here, look at here, the sine theta equal, for example, 1.22 lambda by d, where d is the diameter of the circular aperture. Where d equals diameter of circular aperture. Next one, diffraction grating equation. What is diffraction grating equation? A diffraction grating is made by making many parallel scratches on the surface of the flat piece of some transparent material. That means you are making a parallel scratches continuously in a transparent material, that diffraction grating happen. It is possible to put some large number of scratches per centimeter on that material. For example, a grating to be used has 6,000 lines per centimeter on it, for example. The scratches are opaque, but the areas between the scratches can transmit the light through. Thus, a diffraction grating becomes a multitude for the source with parallel slit. When light falls upon it in this topic, the learners will learn the diffraction gratings formula with example. Let us write the equations of this diffracting equation formula. That is m lambda equal a sine theta m, where m is all numbers 1, 2, 3, 5 is the order number of the diffracted image. It's called order number. What is the concept of the diffracting gratings? Further explanation, the parallel bundle of rays will fall on the gratings. Rays and wavefront form a orthogonal set of. The wavefront will be perpendicular to the rays and parallel to the gratings. Here, Huygens principle is applicable. According to it, every point of a wavefront acts as a new source. Each transparent slit becomes a new source, so crystal wavefront spread out from each. The formula of diffraction grating. Here, consider two rays that emerge, making the angle theta with the straight through the line. Constructive interference will occur if the difference in their two path length is an integral multiple of their wavelengths, lambda. Now n lambda equal to d sine theta. This is a formula where n equal to whole numbers 1, 2, 3, 5. This is known as the diffraction grating equation. N lambda d equal to d sine theta is diffraction grating equation. In this formula, theta is the angle of emergence at which a wavelength will be bright. Also, d is the distance between slits, obviously. D equal to 1n, where n is the grating constant and it is the number of lines per unit length. Also, n is the order of gratings, which is a positive integer representing the repetition of the spectrum. Furthermore, a complete spectrum could be observed for n equal to 1 and another complete spectrum produced when n equal to 2 continuously, but at the larger angles. Now, diffraction happen in X-rays. Diffraction X-ray, that is XRD, is the technique that uses X-ray to determine the structure and arrangements of the atoms in a crystal. Suppose by using X-ray diffraction, we can understand the arrangements of atoms in crystals and other multiple uses. Diffraction gratings of X-ray, how it works. X-ray are scattered when they hit the atoms in a crystal, and some of the X-ray interfere constructively with each other in specific direction. What it can be used for? XRD can be used to determine the structure, crystal orientation, crystal defects, strain, atomic spacing, and grain size of the material. It can also be used to determine the percentage of the crystallinity in a material. What are advantages? XRD is a non-destructive technique, NDT test, that can be used on small samples, and it does not require vacuum conditions. Also, it has some limitation. XRD can't identify amorphous materials, and it does not provide information on profile depth. Optical path length. What is optical path length? It defines the optical path length is simply the distance of the light travels times the refractive index. For example, light traveling through 10 centimeter of water has an optical path length 10 into 1.33. Here 1.33 is the refractive index of water. Then suppose this light travel 10 centimeter, that it is optical path length is 13.3, because 10 into 1.333 is 13.3 centimeter. So far we discussed about the light, of the interference and diffraction of light and its various definitions. We have done. Please subscribe our YouTube channel.